I'm Hunter.
And I'm Doug.
This time on WaterlooLabs, we're going to show you how to remote control drive a real car. Let's roll.
Hey guys, I'm Will. Right behind me here is Wendy, the car we're going to be remotely controlling. Bought her on Craigslist for $300, stripped off the doors for easy access, installed a control system and motors in order to actuate the pedals and the steering. Here's Steven for some more details.
Thanks, Will. So in order to do the gas, the brake, and the steering, we needed 3 different motors. So in order to do the gas and the brake, we tore motors out of the doors that were originally used to control the power windows. We found that 3/4 inch crescent wrenches actually hooked onto the gears on the motors perfectly. We welded it to the gears, and then, in order to get feedback so that we know where we are, we hooked up potentiometers to the motors.
This is a potentiometer, also known as a pot, a variable resistor that we can use to measure angular position. As we turn the knob, the contact slides around the disc and increases the distance that the current has to travel, therefore increasing resistance.
Now these potentiometers are connected to the motors using a flexible connection made out of vinyl tubing. We did a sort of similar thing here with the steering. This motorcycle gear here is used so that we have a connection to the actual steering column.
We had to have a control system, so we actually decided to borrow one from the first robotics competition. Here we're using a Jaguar motor controller that takes a 12-volt signal and controls it with a low-power pulse-width modulated signal. From there we can go back to our digital sidecar breakout board, which then goes back to a digital output module on our embedded compact Rio. We're also using an analog input module to read in all the lines from our potentiometer. Now, this is the brains of the operation, so we want it to be powered at all times, so we have a separate battery for it, and a power distribution board that takes the power and sends it out to all of our other devices.
In order to remotely control the car, we need to get the compact Rio to communicate wirelessly with our laptop. We can do that by connecting the compact Rio to a wireless gaming adapter. The wireless gaming adapter can then bridge an 802.11g network put out by a standard Wi-Fi router. Then the laptop can join the same network to complete communication.
To be able to control the car, we need to know the speed and direction we want to send it off in. To monitor the direction of the power wheels, we have a potentiometer right here, geared up to our steering wheel with a couple of old bike parts. So as I turn the steering wheel, the potentiometer changes its resistance by turning, and we can tell the direction the power wheels is headed in. To monitor the speed of the power wheels, we have an optical encoder glued to one of the wheels.
An optical encoder is a piece of material with varying light intensities. In our case, a PVC pipe with alternating white and black stripes. A photodiode sensor sends a digital signal based on light intensity. For example, a light section of PVC pipe might represent a digital high, a dark section, digital low. If we know the distance between the light and dark sections, we can count the changes of our digital signal to determine distance traveled. Likewise, we can measure the frequency of those changes to determine speed.
All of these sensors require a 12-volt battery supply to power them, and this 12-volt battery supply is also powering this wireless DAC, which is broadcasting all of these measurements onto the same 802.11g network as the gaming adapter and the laptop.
This is the LabVIEW program that's running on our compact Rio. It takes inputs from the iPhone and power wheels via TCP and UDP. It then applies a control algorithm to those inputs in order to determine the outputs to the motors.
We wrote an app so that we can also control the car from an iPhone. Right here we have a slider to control the brake pedal, as well as one to control the gas pedal. And we're using the onboard accelerometers to control the steering. By modifying any of these values, we're changing the numbers sent to the C-Rio over UDP.
So we built this awesome car, but really, it's just a big toy. If you want to find out more about this project and see more awesome projects, check it out at engineerawesome.com. All things considered, you really can't see what's going on.